from Xavier College of Engineering. Uh, I'm the senior assistant professor. A warm welcome to one and all for the FDP program and the student workshop on interdisciplinary applications of AI in electronics and communications. Uh, Today's speaker is Professor and Head of the Department, Electronics and Communication Engineering. First, I thank the organizers and the technical session coordinators and all the participants. A very good afternoon and all the best for the learning. Uh, Saying about the Pongulali Madam, Dr. A. Pongulali Madam, she is from the Department of Electronics and Communication Engineering, and she accomplished her academics over 3 decades of experience in teaching, research, and academic administration. And she has a well knowledge information in analog and digital design techniques. And she has done her PhD from Puducherry University and ME from the College of Engineering, Gudi, Anna University. And done her BE from the Bharatindra University, and she is a senior member of IEEE, and she is a part of the certified internal audit for ISO 9001, and she is one of the member of the active member and the counselor of IEEE technical societies, and a passionate researcher, and she has authors and co-authored for various types of publications which are indexed in Scopus, and also she has so many book chapters, and she has so many IEEE conference articles also. Her main interest of research is in wireless sensor networks, artificial intelligence, and apart from that, cloud computing, blockchain, health applications of AI. And she has written 2 books, which is in the area of digital signal filtering techniques, and she is one of the milestone she is having is an active contribution in the Smart India Hackathon, and also she is a active participator and evaluator of AICTE innovator programs. She has successfully guided so many projects, research projects, and funded projects also. And she has got the Best HOD Award in 2024. And from Knowledge Research Academy, Coimbatore, Tamil Nadu. We are blessed to have you, ma'am, for this session. And today's session is on AI for Embedded Systems, which concentrates on Edge AI, microcontrollers, and smart devices. And very all the best for the learners. And I welcome you, ma'am, for the session. Thank you so much.
Thank you, ma'am. Thank you for your invite. Shall I start, sir?
Yes, ma'am, you can start.
So is the screen visible?
Yes, ma'am, visible, ma'am.
Okay, good afternoon to one and all. First, I would like to thank the organizers for giving me an opportunity to present on AI for embedded systems, Edge AI, microcontrollers, and smart devices. Where this Edge AI is nothing but we are going to see that it is a real-time intelligence at the edge. So this is my agenda of what I'm going to cover, like introduction, the benefits of Edge AI, architecture of an embedded AI, edge computing infrastructure components, hardware powerhouse, and applications of Edge AI, and challenges in implementing Edge AI, and conclusion. So first, let me go for the introduction. So my topic is AI for embedded system, Edge AI. So first, we should see that what do you mean by an embedded system? We know that embedded system is nothing but a computing device which is going to be designed for a particular application. So when you are going to use it is going to be used for a particular, that is, the embedded system is going to be designed for a specific function. Like examples, your washing machines, your drones, tracking system are all examples of your embedded system. So when I'm going to go for my embedded system, so initial days the systems are of generally low power and it can be used in real-time applications and it is going to be a reliable one and it is going to be used for ideal applications there. So in the initial days, we had have embedded systems there, and now an advanced that is we are going to go for the next. This one is going to be our artificial intelligence. So your artificial intelligence is nothing but which is going to enable your computers and machines to mimic the human behavior, and it is going to be a problem solving and decision making and creativity and autonomy there. So here, what we are going to do is we are going to embed our artificial intelligence. We are going to integrate the artificial intelligence in embedded systems. So that by integrating your artificial intelligence into your embedded systems, we are going to increase the operational capabilities of the technologies, and it is going to enable the devices to perform the task autonomously and with enhanced intelligence. So when we do that, we can see that the tasks are going to be done autonomously and it is going to be efficient and it is going to be intelligent also. So that type of technology is going to be called as Edge AI. So in Edge AI, what we are going to do is we are going to deploy your AI algorithms. So where these AI algorithms are going to be deployed directly on the devices. So at the edge of the network. So that means that whatever network we are going to use, at the edge of the network, we are going to implement this deploy this AI algorithm so that we will be seeing the efficiency of the system and it is going to be intelligently behaving. So in Edge AI, we will not be going for the cloud server there. So the basic difference between your IoT and your Edge AI systems is going to be that, or edge computing is going to be in your IoT. So whatever operations we are going to do, we are going to collect the data from the sensors. For what applications we are going to take, we are going to collect the data from the sensors, process it, send it to the cloud, and from the cloud we will be getting the data and then we will be processing it. That is going to be using your cloud server there. But in the case of your Edge AI, your devices are going to be the whatever data we are going to access, the data are going to be processed in the devices itself, and its local processing is going to be done, and there's going to be no cloud server is going to be used. So because of that, the intelligence of the system and the fastness of the system can be improved. So main advantages of going for your Edge AI in embedded system is going to be because of low latency. So low latency is nothing but we are going to see that whatever data we are going to process, the data are going to be processed on the device itself. So it is not going to send the data to the cloud, and it is going to be the decisions are going to be taken at millisecond level decisions there. So mainly when I'm going to go for your autonomous vehicles or for your robotic decisions, in that case, low latency is required, which is the first benefit of your Edge AI systems there. And next is your privacy and security. So in your privacy and security, we are going to say that the data are going to be processed in the device and it is not going to, since it is not going to be sent to the server, it is, we say that the data is going to stay on the device and it is that sensitive information is not going to be transmitted. So by that way, security is also going to be maintained. And next is your bandwidth efficiency. So bandwidth efficiency is nothing but it is going to send that, since we are not going to send all the data, so whatever data we are going to collect it from the sensors, those data are not going to be sent to the cloud. So since we are not going to send to the cloud, we have see that the bandwidth can be drastically, it can reduce the bandwidth, and whatever is the required data, that alone can be sent. So we take bandwidth efficiency. Next is your reliability and offline operation. So here in this case, even if I want to do an Edge AI, that is, if I'm going to implement your Edge AI in your embedded systems, we don't want internet connectivity because we are not going to process the data through the cloud. So since we don't want your internet connectivity, we can say that the system is going to be reliable or it is going to be in your offline operation. Next is your power efficiency. So in your power efficiency, if you are going to see, your local processing is going to extend the battery life. So here in this case, it is not going to since it is not going to transmit, the processing is only going to be done at the sensor level. We can see that the local processing can be done so that we can extend the battery life there. So these are the benefits of going for your edge AI in your embedded systems. So next, if I'm going to compare your edge computing and your cloud computing, so the characteristics, if I'm going to see with respect to location, in edge computing, the location is going to be close to the data sources. That is, it is going to be in the sensors here. So in cloud computing, it is going to be your centralized data sources. And next is the latency. If I'm going to see here in edge computing, the latency is going to be very low, in the range of around 1 to 50 milliseconds. But in cloud computing, it is going to be high in the range of 50 to 200 milliseconds, because the data needs to be collected from the sensor, processed, and then transmitted to the cloud. And from the cloud, it should be got back, and then the data is going to be again processed. So that means that the latency is going to be very high. And the bandwidth usage, since the data are going to be locally processed in the device itself, there it is going to, the bandwidth usage is going to be very less. And in cloud computing, if you are going to see, the data transfer is going to be very high. And the processing power, if I'm going to see in the processing power, the edge computing, the processing power is going to be limited, but in cloud computing, it's going to be virtually unlimited there. And next is the privacy. Since the data are going to be stored only on the devices and it is not going to be sent to the cloud, we say that we are going to have the enhanced local data. But in cloud computing, we are going to see that since it is going to be transferred to the cloud, there is going to be privacy matters is going to be a lot. So we say that it is going to be high with potential concerns there. And reliability, if you are going to see, it is going to vary locally. But in cloud computing, reliability is going to be with respect to redundancy. It is going to be high with respect to redundancy there. So next is we are going to go for an architecture of an embedded AI system. So in an architecture of an embedded AI system, so the main block is going to be your sensor module, where the sensor module is going to be called as the input layer. So whatever operations we are going to do or whatever applications we are going to implement, we are going to have the sensors to be present to detect the data from whichever application we are going to use. So the sensors might be either a vision sensor, or it can be a thermal sensor, or an initial measurement sensor like positioning or movement of the person. Depending upon the application, any one sensors can be used, and this we say it as the input layer, a sensor module. And next is going to be your edge AI chip. So your edge AI chip is nothing but it is going to be called as the processing layer. So depending upon the type of application, what type of memory chip or what type of processor you are going to use, that is going to be decided on the edge AI chip. Our next layer is going to be your memory and your neural processing unit, where in your memory and your neural processing unit, we are going to do the optimized machine learning model. So optimized machine learning model is, so the number of data or the data size which we are going to get from collecting from the sensors is going to be a larger one. So since the devices are going to be incorporated in this in the primary layer, and the memory size is going to be very less, it is going to be around in the range of 32 kilobytes to 1 megabytes. I need to compress whatever data I'm going to get from the application. I need to compress it. So for that, I need to go for an optimization of the machine learning model then. So for optimization of the machine learning model, we'll be doing either the quantization process, the pruning methods will be done. So that we'll be seeing in detail in the next slide. So next is your actuator or decision. So actuator or decision are nothing but we are going to use your motor or switches there. So where these motors or switches, depending upon the application, it should react in less than 10 milliseconds there. So here we say that the actuator or decision is going to be called as the inference engine software stack. So what inference engine means is, it is nothing but a high performance software or hardware block which is going to be specialized for executing the pre-trained neural networks there, so that the power consumption is going to be minimum there. So here the engine is going to process the data and it is going to be executed in your neural with the help of your neural networks, and we are going to see that the power consumption is also going to be very low. So in your edge computing infrastructure components, mainly we are going to have 4 types of components. One is going to be your hardware, the other one is going to be a networking, third one is going to be a system software, and fourth one is going to be your domain variations. So in your hardware, if I'm going to see the basic, so the first step what we're going to do is in your applications, whatever applications we are going to design, the parameters needs to be measured. So whatever parameters we need to measure, that parameters are going to be measured and processed with the help of your hardware. So the hardware is going to be, it is going to include your microcontrollers, your edge servers, your AI accelerators like your general processing units and your neural processing units. And it is going to be, and whatever the storage system you are going to use, the storage system should be optimized for local use. Why it is going to be optimized for a local users? Your edge AI is going to be very small. That is the memory which you are going to have in your edge AI components, edge AI devices are going to be very small. So since it is going to be very small, the data what we want to save it in the system should also be reduced. So in order to do that, we need the systems to be optimized and then the data will be stored. So next step is going to be your network connectivity. So a network connectivity is nothing but we are going to connect. So the system, the devices are going to be connected via your Ethernet or your Wi-Fi or your 5G and specialized protocols there. So that the communication between devices, nodes and clouds can happen. So for that, the next component is going to be a networking components. And third one is going to be your system software. So system software is to operate all the data. Whatever data we are going to get, we are going to model it, then train it, model it, and then we are going to deploy it. So for that, what software we are going to use? The operating system and the containerization of the data should be done. So what we are going to do is we are going to the packaging, whatever is the packaging applications we require, all those applications and the dependencies should be in a portable manner, as well as the quick deployment should happen, as well as the scalability has to be done. So for that, we go for a containerization process, yeah, virtualization process we are going to do. And next is your management, and we should manage the platforms and enable the deployment and orchestration at the edge there. And the fourth, this one is going to be your domain variation. So depending upon the application, what infrastructure is going to be required. Like infrastructure, we have to adapt to the telecom applications or industrial mobile applications, enterprises or consumer needs, depending with tailored hardware and software. So these are the major infrastructure components what we are going to use. So the hardware part what we are going to use is the microcontroller units versus your neural processing units. So depending upon the application, we'll be using any one of these units there. One is a standard microcontroller units there, where we are going to use your STM32. So when I'm going to use my STM32, here in this case, it is going to be used for simple control logic. So suppose if I want to go for your AI enhanced MCUs, in that case I'll be using your ARM Ethos U series, so which is going to do the integration of the hardware acceleration for neural networks. That means that it is going to integrate your neural processing units into the microcontroller. So mainly it is going to be designed on always on, that is whenever I'm going to use for voice wake up or your word detection. So if I want to detect a particular word, in that case I can go for your ARM Ethos U series there. And in this, or a gesture recognition, if I want to do, I can go for this type of ARM processors. So AI enhanced MCUs. Next is going to be your high-end edge semiconductor on chips. So here we are going to use your processor as your NVIDIA Jetson processor there. So in this case, when I'm going to use your NVIDIA Jetson processor, we are going to have that multi-stream data where we are going to have 4K vision and autonomous robots there. That means that when I want to do complex tasks like multi-camera vision for robotics, in that case I can go for a high-end edge silicon on chip there. So next is the power constraint. So power constraint is nothing but whenever I want to go for your neuromorphic chips. So when I want to go for your neuromorphic chips, the neuromorphic chips are nothing but your brain chip ALEDA. So the brain chip Akida process, which is nothing but it is going to act like a human brain. This chip is going to act like a human brain, and it is going to be energy efficient for battery power devices. So in that case, I should see that the power constraint should be reduced from watts to milliwatts, so that the battery power can be long. The battery power can be longer. Next is the tiny machine learning. So where we are going to have the making models fit. So that means that in this case, if I want to fit a model, so whatever model I'm going to have, when I'm going to collect it, train the model, then I'm going to model it, and then we are going to deploy the model. So in that case, the data size should be reduced. So to reduce the data size in terms of kilobytes of RAM, we are going to go for three processes. One is we are going to go for quantization process, which is going to reduce the precision. So whatever is going to be the data precision from floating 32 bits to integer 8, it is going to be reduced. That means that it is going to reduce the model size by 4 times or more with negligible loss in accuracy there. So pruning is the next method where we are going to have in a neural network pathways. So unnecessary neural pathways we can reduce it. That is, we can remove the dead neurons and see that whichever connections that are not contributing to the output, all these unnecessary neural pathways can be removed. That process is going to be called as the pruning techniques. And next is compilers. So compilers is nothing but we are going to use tools like TensorFlow like Micro or Edge Impulse, which is going to generate the compiled C++ code. So that optimized C++ code can be generated using either your TensorFlow like Micro or your Edge Impulses. So here next is the frameworks. So depending upon the application, for which type of application, the different types of frameworks we can use. One is your TensorFlow Lite, the other one is your PyTorch Mobile, third one is your ONNX runtime, and fourth one is your TensorRT and OpenWinnow. So here in a TensorFlow Lite, so this type of software or this one is tool is going to be supporting a mobile and microcontroller. So where quantization on the device training and hardware acceleration is also going to be done. And when I'm going to use my PyTorch mobile, it is going to enable the computation graphs, and it is going to have a smooth transition from research to the deployment on mobile devices there. And next is your ONNX runtime. So it is nothing but your cross-framework compatibility is going to be done with hardware acceleration and graph optimization there. So TensorRT and OpenWinnow is when I want to go for your high performance inference optimized, that is for your NVIDIA and Intel hardware respectively, I can go for this type of tool there. So these are the different frameworks which I can use in my Edge AI techniques there. So the next is your application of your Edge AI in embedded systems. So your application can be, there are different types of applications. So mainly in your healthcare, your automotive applications, industrial automations, consumer electronics, smart interfaces, and generative AI applications. So these are the places where your Edge AI is going to be used in your embedded systems there. So here first your automotive applications. So your automotive applications is nothing but your ADAS features there. So here ADAS features is nothing but it is going to have your safety. We are going to have more safety with the advanced driver assistance system. So in this what we are going to do is in your ADAS features, your radar is going to monitor the distance between your vehicle and the previous vehicle, and accordingly it is going to monitor it and it is going to give you the information. So here in this case, it is going to monitor the road states. Whenever your vehicle is going to depart from the lanes, in that case, that lane departure warnings is going to be given, and your collision avoidance by detecting the vehicles surrounding your vehicle using the radar, and adaptive cruise control is also possible there, where your autonomous driving is going to be feasible there. So by using your ADAS features in your vehicles, we can see that it is going to increase the safety for the drivers as well as the passengers, so that the risk of accidents is going to be is going to be reduced, and it is going to be all these data are going to be got on real-time data analysis there. This is all possible with your Edge AI solutions there. So your ADAS features have come into existence there. Your next up automotive applications is going to be your more better efficiency and your maintenance. So in your maintenance, we are going to get as the car, your car is going to receive a number of data is going to be got through your sensors, which is going to be in your car. All those data are going to be got, and this is going to be processed. So it is going to become more complex, and the chances of the hacking to be possible there. So in that case, we have to do the real-time monitoring is going to be done, so that the energy management can be improved and it can protect the critical functions there. And next is your personal driving experience is the other application of your AJA. So here in this case, your AJA will analyze the driver behavior and it can inform you. So suppose if the driver is going to sleep or is feeling like sleepy, or if his eyes is not focused, then in that case an alert message will be coming on the screen to inform him that take a coffee break. So like that, here with the help of your AJA, it can analyze the driver behavior and it can, and the preferences are going to be for the comfort and convenience. So it can help in adjusting the seat position, your climate control and other settings. And other applications of your AJA is going to be here in this case, your power infotainment, then providing the drivers and passengers with the personalized recommendations for content. So it can suggest what they want to listen, or all those for entertainment purposes. This AJA can also be used. Next application is going to be smart cities and IoT. So smart cities and IoT is going to be there. We have 4 different types of applications there. So where in a smart cities and IoTs, we are going to have the traffic management. So nowadays, previously, if you are going to see, now there's going to be a fixed time. It was the fixed time of your traffic lights, and based on the traffic or based on the uh, traffic density, your timing of the signals was not allotted. But now by using these AI techniques, your HAA techniques, it can optimize the traffic flow in milliseconds and it can reduce the delays. So depending upon the traffic conditions and which part of the road is going to have more traffic, giving them more time to flow compared to the time that is going to be allotted for less traffic roads. So using your AJA, it can optimize the traffic flow in milliseconds and it can reduce the delays. And your next application is going to be a smart lighting. So smart lighting is nothing but it is going to adjust the brightness based on the movement. So here in this case, by adjusting the brightness, and we can see that we can cut the energy used by 70 to 80%. And next is environmental monitoring. So here in this case, your AJA devices will be continuously monitoring the environment and all those data are going to be analyzed on this devices itself. So when it is going to be analyzed on these devices, the bandwidth is going to be reduced by 90%, and in this case, and we can give a quick alert based on this environmental conditions there. And next is your waste management. So waste management is in this case the routes that are going to be, we can see that when we put your Google, it is going to give us the solution that you want to go for a faster route or you want to go for your standard route. So based on this, we can optimize the routes using your AJ techniques, reducing your fuel consumption by up to 30%. Next is we are going to go for your healthcare applications. So in your healthcare applications, we are going to go for your patient monitoring system or your fall detection system and your medical imaging process. So in your patient monitoring system, what we can do is by using your HIM system, we can see that if there is going to be anything, that is when the devices are not functioning properly or if any signal goes other than the expected way or the standard way, in that case a false alarm can be generated by 70% and it is going to work in the offline mode. And next is your fall detection. So fall detection is nothing but it is going to be detecting. So based on your posture and your gestures, we can see that the the patient, the patient is going to be monitored, and if there is going to be, if the movement of the patient is going to be there, and if there is any fall detection is going to be detected, it can be detected with greater than 90%, 95% accuracy, and it can alert the caregivers faster there. And next is your medical imaging. So medical imaging is nothing but we can use your portable AI devices. So it is going to provide the diagnostics without cloud reliance. That is, no need to send the data to the cloud and get the information. Instead, with the help of your portable AI devices, whatever is going to be the parameters that can be the diagnosis of the patients can be done faster there. So if I'm going to go for a consumer electronics, so when I'm going to use my artificial intelligence embedded in your consumer and your personal electronic devices, it is going to give you a personalized experiences. So depending upon my health condition, you know that the tracker is going to be the fitness trackers. Now when you are using the fitness trackers, which is going to give you a personal experiences. Your power efficiency is also going to be more, better security we are going to have, and the innovative features are also incorporated in your the personal electronic devices there. So here in this case, we can see that these devices can be more efficient and it can be intuitive there. So in which it's going to be done with the help of your Edge AI solutions. So Edge AI solutions are going to use your microcontrollers or your processors or your smart sensors so that we can reduce the latency and improve your response time. So Edge AI can be used in your consumer devices like your fitness trackers, used for gesture recognitions, activity recognitions, motion tracking, and more. So many of you would have been using your fitness trackers, which can detect all this and can give your data there. So if I'm going to use it for my cardiac the rhythms, that also a heart rate monitoring. There also, if it is going to be any unusual rhythms are going to be there, it will immediately alert the user there. So here in this case, it is going to provide the personalized health insights and it is going to improve the accuracy of the data. So even if it can be used for your Parkinson's disease or it can be used for your gesture postures, all those things we can use your devices there. So next application is going to be for your smart retail and surveillance. So smart retail and surveillance, we can see that it can be used for your automated checkout. So we know that in abroad now, slowly in our country also, they are trying to enforce it, where we are going to have whatever product we are going to purchase, it is going to be recognized and it is going to be billed automatically, and the payment also can be done automatically. And see, we can see that there is going to be no cashier that is going to be present in the shops. So your first application can be for your automated checkout. And next one is going to be your inventory management. So your inventory management is it is going to detect the stock. So it can directly, it can easily access the what are the stocks that are going to be left out, and it can detect if there is going to be any stocks that are missing. All those can be done with the help of your edge processing there. And your next application is going to be a surveillance. So in a surveillance, if there is going to be any anomalies or any missing in this case, that can be recognized, the objects can be recognized locally and it can be for privacy also. We can detect the anomalies and recognize the objects there. So this is application of your smart retail and surveillance. Your next application is going to be your industrial IoT and industry 4.0, where it is going to be mainly for your predictive maintenance and your supply chain management. So when I'm going to go for a predictive maintenance, it is going to utilize the machine learning algorithms so that to predict the equipment failures. So based on the data, it is going to analyze and then it is going to utilize your machine learning algorithms and it's going to predict the equipment failures ahead of time. And your supply chain management is based on the inventory levels. It can be optimized on real-time demand forecasted. So here we are going to have three this one that one is your predictive maintenance. That means that we are going to analyze the data such as vibrations of the machines, sound or temperature from using the smart sensors in real time. And this using the help of Edge AI solutions, we can enable the predictive maintenance solutions there. So by predicting the defectiveness of the machines earlier, it can reduce the downtime by 50%, and it can see that the lifetime of the equipment can be extended by 20 to 40% then. And next application is going to be a quality control. So in a quality control, it can help to predict us when the equipment is likely to fail. That is, it is going to allow for proactive maintenance after before a breakdown is going to occur. So here in this case, the defects are going to be detected with over 99% accuracy at high speeds. And next is your digital twins and robots, where it is going to simulate the assets and enable the adaptive and safe robot navigation there. So here, these are the applications under Industrial IoT and Industry 4.0. So next is this Edge AI can be used in your home or in your office. Where in your home, if I'm going to use it, we are going to detect the human presence. That is, your human activity recognition can be done, and this Edge AI solutions will smartly control the thermostats, lights, your security cameras, or virtual assistants, and it can be used to provide the personalized experiences according to the daily routines there. So here in this case, it is going to enable the energy savings by turning off the lights and appliances when they are not in use. Next is here this same Edge AI using your Edge AI applications, we can use it in your office purposes also, where we can have the secure entry of the people who are entering inside the labs or whatever it is, we can have it. So on the energy consumption, so suppose if people is not there, then we can switch off the lights and fans so that the energy consumptions can also be done. So we can see that the intelligent motion sensing and the pupil counting, that is how many pupils have entered inside the room, all those can be done, and it can be used in a variety of settings in smart factories and smart homes there. So here mainly the applications where it can use is track the occupancy levels of the rooms, reduce the energy consumptions in the unoccupied spaces, optimize the room utilization and protect the specific areas there. So next is the challenges in implementing your AJA is nothing but one is your resource constraints. So resource constraints is nothing but we are going to have the embedded systems are going to have limited processing power, and then it is going to memory and storage. So since the number of data which are going to be involved is going to be very high, we have to optimize those data and store it in the memory there. So that means that the processing is going to be very limited, and the power required should also be very low, and the memory should also be a very low size, and storage should also be reduced. So these are the resource constraints which you are going to have in your when I'm going to implement my AGI systems. Next is your power consumption. So your power consumption is your battery life. So here in this case, since you are going to use your low powers devices, some applications require your AI models require vast computational power, and the power requirement is also going to be very high. So in that case, the battery life needs to be maintained. So your battery life and the cooling of the battery should also be taken so that the power consumption can be minimized there. So a model optimization is depending upon the AI model what I'm going to choose. The model quantization has to be done, and the pruning and hardware accelerators should improve the efficiency of the system there. So next one is going to be your security measures. So security measures are nothing but the sensitive data should be since we are not the data which are going to be involved at the edge is going to be involved with the data protection. It requires the security measures and compliances also. So network reliability is your edge devices are going to operate in an environment. It is going to be operating in remote environment with intermittent on low bandwidth connectivity. So in that case, we should see that it should not impact your data synchronization and system updates there. So these are the challenges which you are going to face when implementing your AJA. So your conclusion is your edge computing is going to empower your real-time data processing at the source. So it is going to drastically reduce the latency, and at the same time it is going to reduce the dependence on continuous cloud access. So while the challenges are going to be limiting the processing power, energy constraints and security risks remain, your innovations in model optimization and dedicated hardware accelerators are rapidly enhancing the edge device performance. Thank you.
Thank you so much, ma'am. Any
Thank you.
questions? Ma'am, you have given a very insight of
That will be
A
ma'am.
for embedded systems, Edge AI, and microcontrollers and smart devices. You have given an overview of ML models
The
also,
accelerator, capital
applications of edge computing, automotive applications also, and smart cities and IoTs. Waste management was the very interesting topic, and the traffic management, health applications also you have covered. And we are thankful that you have given an insight of industrial IoT and industrial 4 also. And you have also stressed on challenges in implementing the Edge AI. We are thankful for the session, ma'am. And we request the participants to you have any questions, please unmute yourself and have the question. Ma'am, I have a question, ma'am.
Yeah, tell me, ma'am.
In traffic management, in terms of algorithm implementation, the computational cost may vary. So how
Yes.
can we stress on it, ma'am?
So for the computational cost only, we are going to go for the optimization techniques, ma'am.
Okay.
So first we are going to go for the optimization techniques, then we are going to go for the pruning techniques.
Okay.
So by optimization, we'll be reducing the computational costs.
In the prediction also, we can have these techniques, ma'am.
Pardon me, ma'am?
In prediction also, can we have these techniques?
Yeah, we can have it, ma'am.
Yeah. Any questions? From the
Hello, madam. Am I
Yes,
audible?
sir. Yes,
Yeah.
yes,
Yes,
sir.
sir.
So, in our college, we are having embedded AGI course for our TY students, and we are using STM32 controller over there. So, can
Okay.
you guide that how STM32 controller can be useful in solving the problems of AGI?
So depending upon the applications, sir, what applications you are going to use, we can use the microcontrollers there, and we should see how is the data going to be collected and how we are going to model it. All those we are going to do. By based on when you are going to apply, the depending upon the application, it will be varying.
Okay, thank you.
Hmm.
Ma'am, can you give some research gaps, ma'am? Like so many research scholars also have joined. So can you say some research areas?
Research areas, ma'am. Actually, now more applications have come, ma'am. Depending upon your processors, how we are going to process the data, your power constraints, all are going to be a problem there. And the data, how we are going to process and what are the optimization techniques when we can use all matters. So when you are going to collect the data from the sensors, when you are going to model it, and what optimization methods we are going to apply, based on that we can do a number of papers. Then.
Thank you, sir. Yeah, sir, it's up to you, sir. Amarjun, it's
Thank you very much, ma'am. The session
Thank you.
was very nice. I was there throughout. Every slide was very well planned and it was executed properly. We thank on behalf of the organizing committee for your session, very well planned and very well delivered too. Thank you very much, ma'am, once again.
Thank you, sir.
Now we shall move on to the second session, and Professor Wasabi, you can introduce the second speaker.
yeah. I thank the Pongulali madam for the nice session and questions asked by the participants also. Once again, I thank the organizing committee and AMI people for this wonderful sessions. I welcome Dr. Monor Ali is a distinguished academician and a researcher currently associated with Integral University, Lucknow, in the Department of Electrical Engineering, and he has a significant experience in electrical engineering. And he's a faculty member since October 2001, and currently he's designated as an associate professor in the electrical engineering and HOD. He was also worked as an HOD for the Department of Electronics and Communication Engineering from 2009 to 2010, and and the HOD of Electrical. Also, he has worked for more than 3 years. And he has done his PhD and he was expertised in the systems of electronics and communication engineering from the Integral University, and his main area of interest is on image compression. Research interest also includes image processing, pattern recognition, and MIMO antenna design. So his scholarly work was concentrated with published papers of 41 papers in international conferences, and also he has an SCI and Scopus journals. Books also has been published with the topics of smart engineering meter, along with he has a supervising skills of for various PhD students and also PG students. I really welcome to have you and for this session, sir. And sir will be explaining us the AI-enabled IO systems for smart infrastructure and Industry 4. Sir, session is up to you, sir. Thank you so much.
So thank you, madam, for my introductions.
Thank you.
Thank you, Dr. Amis, also for inviting me to give this platform. So good afternoon, everyone, means participants, faculty members, and organizing committee, and the topic here I have selected or you gave me is your AI enables infrastructure and IoT for Industry 4.0. So just minutes. So the content which I am going to deliver you the start the fourth industrial revolutions, architect of smart structure infrastructures, architect for industry 4.0 applications, key components. Then I will discuss some examples. Then if time remains, I will also discuss about the Cisco networking. So 1 minute. So first we will talk about the how we reach up to this fourth IR industrial revolutions. So around you can say that 1760 to 1870, generally mechanical systems are run by water and steam powered mechanical and manufacturing facilities are there. And then in second industrial revolutions, electrical power run by machines are run by this electrical power. Actually, our faculty members, staff rooms are also here. So I might sorry. बेटा जरा ऑनलाइन लेक्चर चल रहा है. So sorry for that. So in the second industrial revolution, all the machines now run by water and steam power. So and the government also start to develop the rail networks, telecom lines, and mass production started. In the third industrial revolutions, that is started, you can say, from 1970 to 2010. So in this era, so which nowadays in India, maximum companies are use PLC, SCADA, CNC machine for the automations. So robotics arms are also nowadays in India, maximum company are using, but this is not industrial 4.0. So here in this, all the things are controlled locally, from the same, you can say, same campus. So in, sorry. In industry 4 means here all the data and all the machines are equipped with sensor transistors, transmissions, wireless transmissions, and data is sent to the clouds. And from the you can say the help of clouds from the remote locations, productions take place. So this is very beneficial because in previous era companies generally produce without any surveying a lot of item and that is based in your warehouses. So now the companies generally in at present we can say that in German and USA maximum company are up to the mark of Industrial 4.0. So they produce their product by live taking the data from a warehouse across the world, and they have take also live data from the customer also as per the need the production is take place. So these are the growth history of industrial regulations from first to fourth. So now this slide is something about the smart structures, smart factories. Smart infrastructure and smart factories means all the things are interconnected. So, no, all like roads, power grid, buildings, waste management, everything are needed for the smart infrastructure. Similarly, smart factories in is industry 4.0. So here machines, product, people's, they should be in contact like a real time process. Similarly, everything means to say everything say will be connected. And the key components for these smart structures and industry 4.0s are IoT, uh, no IoT, AI, digital twins, and cloud and edge computing. With these, all the things, all these components, automations, complete automation is possible. So for this type of work, this is the integrations of, you can say, all the branch of engineering, not only computer science. Computer science uh, experts will work for the AI, and then uh, electrical, no, electrical for the transmission, high power transmission lines, electronics people, civil peoples, all the peoples will have to work together to develop AI enable smart infrastructure and smart factories. So this is our architect for the smart structures. So first layer we can say the need is sensing layer. Sensing means sensing and then transmit to the next layer means communication layer. And then communication layer will send the information to the data layer, and as per the requirements and applications uh, application as per the needs, uh, the result will be in the applications layer. So this is a minimum at least requirement for the smart structure. So everything nowadays in India also, our Prime Minister mission is for the smart city. The smart city means all these things: smart grid, smart meter, distance learning, food and drug safety, public safety. All these are and come under one umbrella: smart infrastructures. I will show also some slide of the government is expanded till now, how much amount ministry concern development, urban development ministry have utilized the fund regarding the smart infrastructure in India. Next, similarly, in the architect for the industrial 4.0. So for this, at least this the minimum requirement to build 4.0, industry 4.0. So here means nowadays robotic arms are in use, PLC, and there's some facility for human machine interface also, and possible if future next generation tools are here. So in 4.0, the section we take data from all these bottom lines, and then analysis, make arrangement for the simulations also, data analysis, scheduling, data visualization facilities should be there, and perhaps data management, classification, different classification, recognitions, image processing, video processing. These things are required for this 4.0 application. So now some applications. I think some network issue is there. I am unable to change the slides here. I'm audible there?
Yes, we are.
Yes, sir. Yes, sir.
Okay. There's some problem here. Oh, slides. Now I am unable to change the slides here. Why this happen?
Click on the slides sir, once.
Going to change the slides now.
Yeah. Yes.
1 minute I will take. I'm going to check what is happening, why this happening here. No, but generally
Health
just
monitoring is there.
yeah, health monitoring. So this is an example, the example showing that how the sensors means first part I mentioned the key component is your IoT sensor. And for student learning in Cisco networking, we can show the students this type of things like smart sensor, different types of sensor Cisco have, and student can practice these things on the system. And this is free using Cisco Net Academy. So different sensors, with the help of sensor, we can develop a smart infrastructure for the hospital. So for this sensor sense the data, and using this process like conversion and signal processing like sampling, taking the Fourier analysis and quantization, which change this information into 0 1. Then electrical people amplify, means electrical expert will use for the real time work, and they will used to amplify these signals. Then we will have to send this signal to with the help of wireless medium to the database center from, and some expert also need to give IP address to all the equipment, means all the sensors which are installed here. So from data management, data, uh, the people classify these things and send the data to the hospital real time, many things. So these are the part of the smart infrastructure. Similarly, second important nowadays is a digital twin concept. So one company in Kaiser, one company Kaiser in US use digital twins for maintaining its compressor pipeline. So digital twins means just a replica of the actual factory, all the equipment. Suppose there is a leakage in somewhere in the pipeline. So they take pre predictive maintenance. They will take all the flow movement, gas position, temperatures, different parameters, and if there is any fault, they will get the real locations that where this is happening. So before the shutdown, they will change it, maintain it. So this will reduce the downtime, and very beneficial for the industry. So Kazer compressors, they are service provider for blower and design and compressor design. What happens generally in our houses, and suppose we have AC installed in our house, and if there is any leakage in the compression line, so generally technician come and again fill the gas there. So we tell the technician to come and fill the gas, yeah, check the system and find out the problem. So industry 4.0 means no need to call the technician, to call the experts. System will automatically send the information to the concern to change the to maintain the hardware. So where we are at present, think every people should have think about that. So this type of things are in German, like a German BMW car. They also take all the data in BMW. They all the data, live data of inside the cars, and they try to remove before the fail downs of the system. So this is main target of the industry 4.0. This is also important part for the industry 4.0, means edge computing. Edge computing is here concern is that no need to send all the data of the industry to the clouds. If possible, make a edge network like LAN and WAN, and locally do all the processing to run the systems. So this will save our bandwidth or cost of the infrastructures. One application of is I have mentioned here. Suppose generally if you visit Indian heavy industry factory, so there you will get railway lines in their workshop, and now this is replaced in where the peoples are working with the industry 4.0. That means suppose a convey of 10 trucks is moving, so that means all the trucks are connected with the local edge network. So they send the data, and only one person in the front vehicles have driver, and rest are driverless. So live telecasting and receiving the data from different type of sensors, and all the vehicles follow each others. So these are in use, and UK-based one company, Wanti at present working on this application of phase for the industry 4.0. Now, next, another example. Here, one company is a watchdog agent. So what they are generally doing, they maintain the engine of the bulldozer. Suppose one bulldozer is working in the remote sites, and what is the conditions of the fuel, what is the condition of the temperature surrounding the engine body, and exhaust gases condition, all these things, and they live receive the data. So if there is any problem, they immediately work for that to save the bulldozers. So these are the applications of IR for technology. So watchdog agents of USA give this type of service. Now this work I have done here also key for you can say health monitoring of the transformer oil. So, but this is not as per the AI for what we peoples here do that we take the samples and then we have database. Then we compare the thing with the database, and we find some algorithm suitable algorithm for the accuracy and for the speed to reduce the complexity to and compare result with the others and got a good publications. But AI 4.0 means what are the industry demand is something different now. Because suppose in our campus this and how many transformer is there in any campus, 2 or 3 high kVA transfer or and there generally there's no liquid in electronics transformer, but high rated transformer have oil, and work of the oil is to separate the primary winding and the secondary winding, because primary and secondary are connected by mutual induction, not they are connected by electrical line. So generally what happen after passing the times, the gases or many gases you can say dissolve in the, and reduce its dielectricity. The actually the oil is a good dielectrics, and by absorption of heat due to the copper loss, there are so many losses for running the transformer: copper loss, eddy current loss, and these losses dissipates energy inside the oils, and so the oil condition become worse. So what happens generally in summer in many areas, transformer breakdown suddenly. To save that, we can maintain it by taking the samples, regularly taking the samples, and we generally send it to the chemical lab to find these gases generally, and when degraded, hydrogen, methane, ethane, carbon dioxide, carbon monoxide, nitrogen, oxygen, and proper their ratio. We calculate the ratio in ppm per million. How many molecules of methane or ethanes are there in a samples. But these are wasteless for the industry 4.0 by taking the sample. Generally, I am from Lucknow here and at present. So for this work, my students visited nearby state government labs. So labs, and also they have maintenance facility of the transformer. So what happened? They generally check the by applying voltage for the breakdown, and they check dielectrics. If it breakdown at the low voltage, that means condition of the oil is not good. So they simply change the oils. But industry 4.0 is nothing about this. They will use relevant gas sensors, and then send that data, make arrangement for the data. So here for the resources, these are the gap nowadays, and generally computer science people or software people, uh, they will not work to take the real time data, so this is the challenge, and they take samples of data from somewhere, and then train their models. So we people present and publish a good paper by using a new algorithm, applying new algorithm to find the health of the we can find anything, but the challenge is again how you will get the real data. So some things, and I also how our country is moving for the smart infrastructure. So here Government of India is working for all the things for smart transformation, smart building, smart utility, smart citizen services. So here this around 179.7 billion USD estimated with the market in India for up to 2033. And mostly at present people are living in the rural areas, but up to 2030. So people means city will expand and maximum people will use these smart things. So this is some statistic informations, what is the market and what is the expectation of the growth. And this data I have taken from the Ministry of Housing and Urban Development. So up to December 28, Government of India invested in so many key sectors for the smart infrastructures like solid waste management. So many you can say big and old cities, yeah, important cities of the state, uh, government are investing many for the solid waste management, uh, did door-to-door collections of the waste, and then use this to reproduce electricity and urea and many items. So uh, everywhere now uh, departments are working to develop the smart infrastructure. So IT connectivity, ICT solution, urban mobilities, every sector government is trying to uh, develop the smart infrastructures. No complexities here. This slide is enough. So there are so many complexities for the smart infrastructure also. And so nature of the city, some city are coastal areas, and mountains are there, some are the historical cities. This is the figure, the linkage of Lucknow. This bridge is ancient bridge, you can say. This is built around 18th century, okay, by in the era of last Nawab of Lucknow, Wajid Ali Shah. So I want to say that how this is a challenge to develop this area for big challenge for the smart infrastructures. Means connectivity of all the persons should be good, and all the facilities like live telecast of health monitoring should be from this location also to their hospitals. So these are the challenges for the AI. AI means every engineers nowadays have challenges. For new cities, and they are like this is a photograph of Telangana capitals. So they are trying to develop good city with all the basic, try to give all the basic requirement for the smart infrastructures. But lot of work we have to do for all the things like traffic situation in all the cities, and still need to think what we can do and how the live telecast will have to send. And we have Google Map, but only Google Map is not here to resolve another issues like some alerts to go there and move away from there and take another routes. So these are the work we can things to minimize these issues. Similarly, issues of garbage still everywhere. So we have to incorporate all these things for the solution of smart infrastructures and Industry 4.0. So now, if time is here, so okay. So I will see some Cisco tools. So why this is nowadays important for the at least you can say electronics and electrical engineer to work with this networking tools. So now I'm going to open Cisco networking tools. Okay.
Attend.
So now Cisco packet tracer is now visible here.
Yes, it is visible.
Maybe many of participants are aware of this, but I think we should give information this platform to add this topic in their curriculum also, because in maximum university this subject I feel that not in their curriculums. So in this student will practice and Cisco is one of the Z company of the network, routers, switches, every components are here for the you can say practice for test. Suppose this area is called workspace, and suppose we want a local network to you from the bottom side, and you take any hardware, means here it is called in devices, so you take this one and a PC, laptop, many laptop, many devices, and if you want to connect these two things, so at least you require some switching device, and no need to use a router for this small network. So you will get here many things. Okay, so, what the bottom, the one thing shifting these things. Mm. So laptop is there. So now there are so many switches. So nowadays the switches are also smart switches. So the switches are used to connect all the in devices. You can say for the architect of data communication layer. So this is layer one. So these are the different switches, and as per the need, you will have to use these switches like these switches have 24 connectors for the fast Ethernet. That means 24 devices you can connect with these switches, and two ports are for the gigabit Ethernet, means for the high bandwidth, and one port for the VLAN. And for the connection, and these are the part of the I am saying that for the industry 4.0, and industry 4.0 means integration of all the area, and not it is one person or one branch specialization area. To not to connect this these here they are the connectors. So first, if you will take put it here and connect this one to here, up to bring it to the switches. So now there is a connection between this one and this one. Similarly, you bring this, and my aim is to make the connection and to check the connectivity, and whether these are connected or not. So suppose I'm going to connect these two one. So for that you will need switches, and if you want to connect two LAN and two different LAN, so next you will require routers. So at present there no need to routers. So now need to give some name or some identification. So for this you click on this one and click on the configuration. So your interface. So we have used like fast Ethernet. So for the fast Ethernet now here you enter IP address. So IP address, IP version 4. Version 4 means this is 32 bits. Now there are many class of IP, class A, class B, class D, class C. So all the things you can practice there, but commercially you will have to pay for the IP addresses. So for practice, Cisco have given all the things. So like I am giving this IP address for this computer. So 10 point, suppose 10, 10.10.10, 10.10. So subnet mask is 255.0.0.0. So this means 255 is network ID, and 10 means 32. Actually the length is of 32 bit. It is written in hexadecimal 4 bit space. So sorry, 8. Hello, I am audible. Okay, so now close this one. So 10 10 10. Sorry, PC 0. Now to remember the IP address, you can write here IP address also. Someone is mic is on, maybe 10.10.10.10. So this is IP address of this PC 0. Similarly, give IP address to this laptop. So again, click on this laptop. You will find everything. Sorry, someone mic is on. So for the configuration and for this one, so for fast Ethernet, so give the laptop some IP address. So because it is in a single in a LAN, so give it the same network ID. So this network ID should be 10, and rest you can change, like 11.11.11. Just only for the practice. So 255 is submask, and 000 means these are the host number of hosts. So 24 bit. This is actually 32 bit numbers are here. 0 to 256. Sorry, 0 to 255. So actually it required 8 bit. In 8 bit means binary, and you convert it into decimal number to 255. So 255 host, and 000 means 404040. Maximum value is F. So maximum value means you can put here. You can put here F. So 11. So now Control C and close this one. It is taking times. Again, I will write this here. So both the IP address and we have assigned. So now, if you want to check the laptop is connected with this PC or not. So now click on anyone and come on the desktop. Many things are here, and these are free software. Student will have to create a coordinate to Cisco Net Academy. Everything is free. A student can give their exam for the certification also. So click on the command prompt. So now suppose I am checking the PC0 connection with the laptop. So for this, the command is ping. Ping is very popular command for the network engineer to take to check the connectivity of the lines. So ping and give the IP address of the laptop. So 10.11.11.11. So the results. So again, ping. Means initially it was invalid command. Now I have not given the space. Now both are connected. Means 4 packets are sent from the PC0 and just less than 1 millisecond replies from the laptop that okay, I am here. Okay, I am here. So statistic is also here. Send 4 packet, receive 4 packet, lost 0. And average 0 millisecond. Maximum packet take 2 millisecond to reach from source to destination to again return back packet from destination to source. So the other nowadays I think these things should be included in the undergraduate course also to start to send the actual data, real-time data from the ground reality, ground plane to the data server. Similarly, mm, for industry, many things are here. Like for the wind energy, solar panel, everything are provided by the Cisco. They have hardware with they sell this product. They have given mentioned everything, their numbers, and you can find these numbers from the Google's and what are the minimum requirement, what current voltage required, every statistic they will send. Like you can control here for your batteries are here, ACs, we can control the ACs. So here I would they are mentioned IoT 0, IoT 1, and these are the devices are here. Similarly for home automations, you can control the fan from the remote location. You can control the door. If you click on this, in any one of this, you will get all the specifications. What are the requirement, how you will configure this. Similarly, like I have configured and laptop and PC. You can configure same thing there also. Look, everything they have shown here. Zoom can switch off here, switch on here. Adapters is here. So what are the voltage requirement? 110 to 20, everything they will provide. And Cisco have all these things. So no need to purchase all the things. How much you will invest but do compulsory these things in the lab for the electronics engineer also. So I think this is about these things from my sides. So anyone who are listening, so thank you.
Excuse me, sir. Am I
I
audible?
think now, Anna, this was from my side, Anna. If there any question from the audience, please.
Yes, sir. Hello.
Ji, yes.
So, what is the concept of smart cities? If you see, let it be in tier 1, tier 2, whatever the cities, we are saying the smart cities. But exactly, if, if we take the case of what drainage water system,
Yeah.
then also it is for a small time of rain, everything is disturbs. Then how we can
Actually,
say, then how can we implement in this case the IoT concept?
these are the step-by-step process, and you cannot say that now we are become the smart cities, So all the agencies, people's, all work together for the smart, you can say infrastructure as smart cities. It needs a contribution by all the entities, not only administrative, not only here called Nagar Nigam, peoples. So all the citizens will have to work to develop for the smart infrastructures. And government they started to fund, they have a ministry for that, and they have planned up to 2030 to develop 100 cities in India to upgrade. Smart city means not a new city. They will upgrade the old city, already developed cities.
Okay,
No,
sir. Thank you.
any question?
Okay, participants, do you have any question to ask? Our resource person is waiting. Even if you come across some questions related to the topic today, you can contact Mr. Manovar through me, or directly also you can contact him and get your queries resolved. Thank you very much, everyone, for this great session today. Hope to join tomorrow at the same time with new topics and new resource person. Thank you, everyone. Have a very nice evening.
Thank you.